Good morning to you. I'm Danilo Evangelista, and welcome to our tropical weather video today, June 4th, 2024. Today, I really want to go over, of course, what is going on across the tropics, but also what is going on with the modeling, because sometimes that plays a huge part models play a major role into how we track hurricanes, especially when it comes to predicting them. And I feel like, especially when it comes to models like the GFS, it is always really important to really dissect them and determine sometimes whether or not they're accurate, especially in the cases like the GFS, where sometimes, and you can even see on the title card, we have runs like what you see on the title card where the GFS has a hurricane slamming into Florida or someplace. But the question remains, is that actually accurate, or sometimes are models just showing things because of their biases that they have in predicting stuff we're all going to go over today, or at least I'll try to be able to go over it to the best that I can, and hopefully maybe you'll be able to learn something out of today's video. Glad to have you along. Let's get started with a look at the National Hurricane Center page. Nothing expected over the next week, at least by the National Hurricane Center, so that should already tell you something, at least when it comes to models. And even in the Eastern Pacific too, they got rid of that area of interest, which was only a low chance. It finally is gone. Doesn't look like there's anything going to happen out of that anyways, and the Eastern Pacific over the next week is supposed to remain quiet. Here's a true color view of the Atlantic, taking a look at the Atlantic in true color so we could see the ocean for what it is, I guess, and also the clouds too. Lots of cloud cover over the southwestern Atlantic, near Bermuda. I think this brought lots of rain to the Caribbean islands, and it's now just a whole big mess that is in the southwestern Atlantic. And it's especially a mess because you can see lots of strong upper level winds still present in the Atlantic. We still do not have relaxed wind shear yet. And until we get any sort of relaxed wind shear, we're really not going to get too much developing in the Atlantic. And you could also see, once again, something that I really want to point out is lots of mid-level dry air out there right now. Very typical of this time of year. We're really not conducive anyways in the MDR just yet for development. And of course, it'll probably remain that way for the next few weeks. Development doesn't really occur anyways in the MDR or the Eastern Atlantic till by the time we get to later July and early August, even though it is entirely possible that we could still potentially get development in this region of the Atlantic sometime later this month. Once again, the biggest area we want to focus, though, for the month of June is in the Western Atlantic, especially over the next several weeks, which will once again go over that there might be a window of opportunity opening up in the Caribbean and Gulf as we head towards mid-month. But definitely it's not happening right now, though. Here's actually a look at the upper level winds, just to kind of give you perspective of how the winds in the upper levels are stacked right now. And one thing that I'll tell you for sure is when you especially see all these wind bars stacked on top of each other like this, that definitely means that there's lots of strong upper level winds in the atmosphere. So wind shear cutting across all convective activity we have in the Atlantic. And we know for tropical cyclone development, that is not favorable. This is not the look we want to see when it comes to determining whether or not upper level conditions are favorable for development of systems. We want to look more towards something like we see over here, where we see not that many wind bars representing that the upper level winds in the atmosphere are weaker. We do not have widespread of these weaker, more spaced out wind bars, though, because there's lots of strong upper level winds right now. And while that remains the case, the Atlantic will continue to remain quiet. Taking a look at sea surface temperature anomalies updated as of June 2nd. We still have the June 3rd map that I guess we got to get. It is still pretty early for it, but it doesn't really make that much of a difference. The MDR still remains well above normal. The entire tropical Atlantic, at least a full degree Celsius or so above normal on average. Some areas even nearing 2 degrees Celsius on average above normal. Basically, that just means the Atlantic is much, much, much warmer than it should be. Really throughout the entire Atlantic, not even just the deep tropics, although the biggest concern that I have is that most of the heat that we see in the Atlantic is concentrated. The majority of the heat is concentrated in the deep tropics where it should be, especially in order for us to get the most out of rising air and favorability of conditions in the deep tropics, because that's where the development really does occur. And there's also other mechanisms too, as to why um, heat focusing, especially in the deep tropics, is really important for a favorable hurricane season pattern. But the general bottom line is that this look is definitely a look of an active hurricane season, especially with La Nina developing in the Pacific. This has been modeled by the climate models for the last several months now, and it is now happening, just like the Atlantic being super warm is also happening as well. And all the climate models are hinting at this year potentially being a very active hurricane season. So you put the two together, and these are all definitely setting up the expectation that this year will indeed be a really active hurricane season. And really quickly, kind of focusing once again back on the Atlantic. This is an average of not the MDR as a whole, but just the Eastern Atlantic. So this part of the Atlantic, the technical MDR that many people use, between the part between the Windward Islands and West Africa, that on average right now, at least per the Neural Coral Reef Watch. So this actual data set, if we take a look at it on an average set of the entire Eastern Atlantic, we're on average almost 1.5 degrees Celsius above normal. And you could even see over the last week, we've dramatically began to warm up once again. The Atlantic sometimes tends to have these periods over the course of several weeks where it kind of tanks down, and then it warms back up, and then it goes back down again, and then it goes back up. Kind of has to do with Saharan air and the fact that atmospherically we're just not really as unstable right now. So we sometimes tend to go several weeks where we go up and then we go down. And also models are really heavily influenced by dry air, and not models, satellite data, especially when it comes to measuring the sea surface temperature anomalies, because you would think that these are measured by buoys and stuff of that nature, but they're also measured by satellite data as well. And satellite data gets very skewed by stuff like dry air, especially Saharan air. So sometimes that's why we get these huge dramatic swings in the sea surface temperature anomaly graph. But if we take a look at it from an overall scheme, the Atlantic is well above normal. And that just means there's so much heat in the atmosphere for the Atlantic to use that it definitely will be ample enough for a really big hurricane season this year. When it comes to modeling, though, what do the models have? Because thank God we don't have anything to take advantage of it now. And at least when we look at the GFS over the next week or so, it does not seem like nothing of any crazy significance does happen, except if we take a look at the Caribbean. And this is also generally part of models starting to kind of come to the idea that as we get towards the mid part of June, things will become favorable in the Western Caribbean as a whole. And I guess the GFS, once again, really hammering down on that idea. This is hour 168, right where we typically would want to stop it and not go any further due to confidence. The GFS does seem to have something. We see a lot of vorticity generally beginning to concentrate near Florida. But I do want to take it out further than 1 week, though, because I do want to point out the GFS, obviously, of course, then makes this develop much more significantly as it heads out into the Eastern Atlantic. But I do want to point out, because this is the GFS that we're talking about, and obviously this does start from just this kind of small area, not small, but very disorganized area of vorticity, to suddenly the GFS is spinning up what's probably a formidable tropical cyclone as it heads northeast away from Florida. And why is this significant? Because sometimes what the GFS tends to do, and the GFS is a pretty good model to look at when it comes to tracking, but it definitely does get sensationalized, especially whenever we have these so-called crazy runs once in a while, where the GFS tends to really lock in on an area of convection and vorticity. We call it the convective feedback bias that the GFS tends to have. And the result of that is exactly what you're seeing. We have these spin-ups that the GFS makes and overblows them. much more than sometimes what they'll actually be. Although sometimes the GFS might actually be hinting at something, because let's take a look at the 0Z run. And we could still see, if we look at it, if we run it in time, you could still see there's some sort of vorticity area that comes out from the Caribbean, and then does actually indeed maybe try to consolidate a little bit. But notice the difference from the 0Z run to the 6Z. The 6Z run looks like a formidable, actually decent looking, probably tropical cyclone on the model, whereas the 0Z, it is just a whole bunch of disorganized mess that the GFS has, and it's nothing that is nowhere near as concrete than what it shows on the current run. And we could even take a look back at that on the 18Z run. You could see maybe somewhat more concrete than the 0Z, but definitely you notice the difference. The 0Z, the GFS is very inconsistent, especially in these kind of modelings. They tend to be very inconsistent. And another way to really test the inconsistency on the model that the GFS has is taking a look at other models. Another model we could look at, especially, is the European. And this is actually the model that a lot of people tend to use in order to test out whether or not the model, like whenever something the GFS shows, may actually be accurate. And let's take a look at that on the European and see what they show. And we could see all the way out to 240 hours out, European has absolutely nothing, nothing especially compared to this. Let me just really quickly bring it up here. This is at hour 198 on the GFS. We see a very formidable area of vorticity. Definitely looks like a signature that we would look at when we're determining whether or not the model is trying to show some sort of tropical cyclone developing. That is hour 198 on the GFS on the 6Z. And from the 0Z European, I guess that translates to hour 204. All we see is stretched out vorticity across the Atlantic. So nothing concrete. And that is one way you could definitely tell whether or not these, especially these GFS model storms, tend to be accurate. And that really comes into question sometimes when the GFS shows, and this was a run from several nights ago where the GFS had a system. This is actually the European still, not the GFS. But the GFS was showing, and I think a lot of people were talking about this run. Let me bring it up. This one, the GFS had a very strong, formidable system heading into Florida several nights ago on the GFS run. And even then, let's take a look at the European from back then. Let's actually bring it to the 12Z from that day. And you notice even there, this is the European from the same day, and all the way out to 240 hours out. The European has nothing in terms of any sort of concrete development ongoing, while the GFS has, at that time, let's go back to it, 18Z on the GFS. The GFS has a concrete hurricane, or probably near hurricane strength storm, near Florida. So the question when it comes to the GFS models, especially because the GFS is very much known for doing storms and showcasing sometimes these modeled hurricanes, or some people like to call model canes. The question is, are they always accurate? No. And that is something that is very significant to take away from, because sometimes it could skew the perspective of the chances of something that has to develop, or I should say, it makes sometimes the chances of something more than what it seems, especially when you compare it to the other models, which may be showing nothing, but the GFS has a formidable hurricane out of something. It tends to skew what we think about the storm, and it definitely also gets a lot of hype and leads to a lot of misconception by people, but from the general public, because they're not familiar with the biases that sometimes models like the GFS have. And then we see people sometimes taking to social media, posting these model runs, these crazy sometimes model runs of the GFS, saying that there's the potential for something to occur, when in reality, it is just a modeled hurricane at the end of the day that sometimes the GFS spins up. So this is really something that a lot of us should keep in mind as we head towards the season. And it's a huge part of tracking too, because these models help us determine really forecasting when it comes to these storms. And when we take the models and twist it in a different way than what they're intended, it really tends to twist and skew the way tracking is supposed to be. And that's why it's really important to mention when it comes to when it comes to these storms that the GFS sometimes tends to spin up. And especially why, if you notice that while everybody was mentioning that the fact that the GFS several nights ago had this not huge, but you get what I mean, formidable looking storm into Florida, I didn't mention it at all. It's because for this reason, the GFS sometimes tends to be unreliable when it comes to quickly spinning up something more than it is. And we could even take a look at it. This, I guess, is another way to kind of put it into perspective. A tweet by Andy Hazelton. He mentions that that in about a week we'll have a stream of moisture from the Caribbean towards Florida with an upper trough to the north. The GFS and the CMC show a weak low pressure developing, although the flow structure would make it difficult to organize, while the European just shows a moisture stream for now. And I'll show you, this is what he actually has, all the models side by side. And then you can see both on the GFS and on the Canadian. That's what the GEM, the CMC model is. It's the Canadian model. They have low pressures forming, while the European just shows moisture. So it shows the difference between models, and it also shows the importance on why we should not just look at one model and take it for what it is and look at all the other models. So with that, we could definitely say, at least when it comes to this current model run where the GFS has something off of that does seem formidable, maybe it could be a signal of something. Maybe we could see the other models catch on to it. That sometimes happens as well, that the GFS may be showing something very formidable, but the signal in reality is still credible, and the models end up catching on to a signal that is somewhat similar, but obviously is not what exactly the GFS model shows. So maybe this could be something. But at least when it comes to determining whether or not this will actually develop, I'll probably say not. And at least over the next week or so, once again, I think things will probably generally remain on the quiet side. So that is that. But I do want to mention, though, at least when it comes to development, even if we're not looking at something right now, I'll definitely assure you that within the next few weeks, once again, we will be looking at something for sure in our part of the basin. As again, I am saying that this is probably, even if the GFS has some sort of bias with what it forecasts, I do believe this is probably the models beginning to latch on generally to the idea that that conditions are generally becoming more favorable in the Western Atlantic, right on the start with hurricane season in June. And I could even show you here, typically we look at the European for this kind of map, the rising motion, but I decided this time let's bring on the JMA model. Sometimes other people look at the JMA, so I thought maybe today we'll look at the JMA. And this is the main graph that I want to show you, this top graph right here. This is the velocity potential anomalies, and the blue in this map, it's usually green, but this map is blue, represents rising motion in the Atlantic, and this was initialized actually I think last week, but still it goes to show rising motion in the Atlantic for days 17 to 30. That is mid to late June, and that is the time frame everybody is watching that the window for activity could open up in the Atlantic. And I'd say I'm inclined to believe so, especially with how warm sea surface temperatures are basin wide. Wouldn't shock me if something happens for sure. And wouldn't shock me if maybe some of these model storms that the GFS has right now in some form ends up coming to fruition over the next several weeks. We'll have to see though. But that's not to say the GFS is a horrible model. Sometimes it can be really good, but sometimes there are inaccuracies in the model, and hopefully that's what I was able to point out today. With that being said, though, really hope you enjoyed the video. Really hope as well that you learned something. And if you did, and even if you didn't, like, comment, subscribe. Tell me what you think in the comments as well. Tell me your opinions. Tell me if I missed anything. Hopefully I didn't. With that being said, though, thanks for watching. Stay safe. Peace, love, and kindness to all. And we'll talk again very soon.